All right, welcome back to another week. Hope you guys had a great weekend. And today in pre-calc, we're going to talk a little bit about our exponential equations. So last week we talked about how to graph them. This week we're talking about how we're going to solve if we have exponential equations. So here we can see these are exponential equations simply because they have some sort of exponent. And in our case, there's an x in those exponents. So right here, what is the process? Our first step, and this is not always going to be required, but our first step is to get the bases the same. Oops, that's not a G. So our bases, we want to get the same. Now, the reason I say this isn't always the first step is because sometimes this is already done for you. So if we try to get the bases the same, if we look at example 1 here. On example 1, they have 3 raised to the 5x minus 1 and 3 raised to the 4x plus 2. The base is the large number, the normal size number. So in our case, for example 1, we have the base of 3 on both of those. Now the reason that's good is because if I have the same base, 3 raised to the second every single time is always 9. 3 raised to the third every single time is always 27. So if these both have the same base and they are equal, that tells us they have to have the same exponent. That's the only way this could be the case, which means once I have the same base, I can simply kind of eliminate that and just deal with the exponents. Okay, so 5x minus 1 will equal 4x plus 2. From here, it's an algebra 1 problem. So subtract your 4x from both sides. We get x minus 1 equals 2. Then we just add over 1, and we get x equals 3. So I forgot to finish my steps. Step 1, get the bases the same. Step 2, you can cancel the bases out once they are the same. And then step 3 is just solve your algebra 1 problem. Okay, so example 2. This one maybe is a little more challenging because right now this is 2 raised to 2x plus 3. This one is just the number 32. However, 32 can be an exponent with a base of 2. So if I rewrite this, 2 raised to 2x plus 3 equals 32 is the same as 2 raised to the 5th power. Okay, so 2 to the 5th power is 32, which means now I have the same base, cancel, cancel. I'm left with 2x plus 3 equals 5. From here, subtract 3, and we get 2x equals 2. Divide by 2, we get x equals 1. Now, if you ever are second-guessing yourself and want to know, did I do it right? Just plug it back into the original. So right there for the x, 2 times 1 is 2, plus 3 is 5, and 2 to the 5th we know is 32. So we did it right. All right, so sometimes we're going to have to manipulate both sides, or we're going to manipulate it and there's still going to be something up there. That's okay. So if that's the case, right here, 25 and 125, we can get both of these to have a base of 5. So on the left side, I'm going to do 5 raised to the second. That's the same as 25. However, it was already raised to 2x, so I need to put parentheses and 2x. And likewise, 125 is 5 to the third. We have to put parentheses and then x plus 2 because that was already up there. So anytime that happens, you can just use your parentheses and then distribute. All right, at this point now we have the same base. So we have a 5 for both of them, which means that can cancel out. Now we can distribute. 2 times 2x gives us 4x. Or in that case, just multiply. But then we distribute that 3 in and we get 3x plus 6. And from here, all we got to do is subtract the 3x from both sides. We're left with x equals 6. and we are done. And once again, if you want to check it, you can. 2 times 6 is 12, 25 to the 12th, and then you do 6 plus 2 is 8, 125 to the 8th. If you do that through your calculator, I don't expect you to know how to do that in your head, but if you do that, you're going to get the same thing. All right, now our next one, we got 81 to the 3x minus 4 and 9 to the 2x plus 1. We know that the square root of 81 is 9, so 9 to the second gives us 81. And over here we have 9 to the 2x plus 1 still. Now here's the deal. Both of these, if you wanted, you could have gone farther. We know that 9 breaks down to 3. But if we do that, it's just an extra step. You don't have to do that, but you could if you wanted to. And there'd be 3 to the second, so you'd have another 2 out here, and then 3 to the second, you'd have another 2 out here. But we already got the same base, so we don't need to do that unless you really want to. So distribute that 2 in, because our 9s are going to cancel, and we're left with 6x minus 8 equals 2x plus 1. Subtract the 2x. 4x minus 8 equals 1. We add 8. 4x will equal 9, and then divide by 4. And just so you know, sometimes you do get fractions. That's life, okay? Fractions are not illegal. They exist in the world, okay? They exist in our real-life applications. So that's fine. If we have a fraction, keep on moving. Sometimes that happens. All right, now the final thing we got to talk about that's a little different is, look here, we have 1 over 9. So my question for you is, what do we do if we have a fraction? So think for a minute about what you know about exponents and how we can get a fraction. Okay? And if you don't remember, this occurs when we use negative exponents. So anytime we have a fraction, my advice to you is worry only about the bottom number. If it's 1 over 9, just worry about the 9. To get a base of 3, 9, we need 3 to the second. However, since it was a fraction, it will be 3 to the negative second. That is what took it down to the bottom. So 3 to the x equals 3 to the negative second. Those 3's cancel, and we already have it solved. X equals negative 2. And just like that, we're done. Okay, your next one, 1 over 16, and that equals 8 to the x minus 2. Now be careful. 8 and 16, I know you're going to think it's just 8 to the second, but 8 to the second is 64. We actually on this have to change both of those. 2 goes into both of those, so 2 to the negative fourth on the left, 2 to the third on the right. Don't forget your x minus 2. Our 2's are the same, so we get negative 4. Oops, that's not my best. Negative 4 equals, distribute that 3 in, 3x minus 6. Okay, so now from here we add the 6 over. And we're going to get 2 equals 3x. Divide by 3. And x equals 2/3. And we're done. All right, now, before I finish for the day, I want to show you guys the 2 most common mistakes that I've seen over the years, okay? So in my experience, these are the most common mistakes. So again, on the next page, there's an example of a problem done incorrectly. You need to find the mistake and then solve it correctly. So if we look here, 4 to the 3x equals 8 to the x plus 1. They rewrote that as 4 to the 3x equals 4 to the second times x plus 1. Distribute the 2 in, subtract it, and we get x equals 2. However, there is a mistake here. Okay? See if you can figure it out. They used the wrong base. Whoever did this, use the wrong base. I know that it's tempting because you're thinking 4 times 2 is 8. That's not how exponents work. Okay, 4 to the second is not 8. 4 to the second would be 16. Because remember, exponents mean 4 times 4. Okay, so instead, they use the wrong base here. Instead, if we have a 4 and an 8, we actually have to change both of these. So it's going to be 2 to the second. That's 4. Okay. And then for 8, it'd be 2 to the third. Now, get rid of the 2's, multiply 2 times 3x gives us 6x. 3, and if we multiply that in, we get 3x plus 3. Okay, from here we subtract 3x. So 3x will equal 3, and divide. X equals 1. That is how you would solve it correctly. Okay, so now the final example. Once again, another common mistake. We look here. They took 2 to the 2x minus 5. They rewrote that. They knew 2 to the third for the 8. If you notice here, though, then they solved it correctly from there on out. 1 over 8 is not 2 to the third. 1 over 8 needs to be 2 to the negative third. Okay, so that should be 2 to the x minus 5. We leave that. Oops, I wrote that wrong. 2 to the 2x minus 5. But then 1 over 8 is 2, because 8 would be the 2 to the third. It's a fraction, so 2 to the negative third. Okay, so a second common mistake is forgetting the negatives on exponents. So forgetting the negatives, and we always are going to have to deal with a negative when we have a fraction like that. So now that we got it set up correctly, we can just do 2x minus 5 equals negative 3, because those cancel. Add the 5 over. 2x will equal 2. Divide by 2, and we get x equals 1. And once again, we have solved it correctly. So if you have any questions, please let me know. Please make sure you do the practice for today, and hope you guys have a great day, and I'll talk to you later. Bye.